Okay, so I want to review LINQ a little bit, just since it's been a while since we've talked about it, and particularly left joins, which we were talking about last time in class. But just to quickly recap LINQ, it's a way of writing queries directly in C#, and those queries get translated to database queries, in our case SQL queries. And the things we're querying are C# collections, classes, that mirror the database tables. So db.players, for example, is a collection that was generated by the automatic scaffolder tool, and it mirrors the players data table in the chess database. So I've written this query: players join games on PID equals black player. This is essentially just giving us all black players. And the result is this thing called query, which is actually an IE-numerable, which means we can do a for each loop to access all of the things that come out of query. And the things inside of that query are players, but the reason we know that is because we are selecting P, which is coming out of players. If I was selecting G instead, then it would be an IE-numerable of games. And if we want to select multiple columns or multiple different types coming out of the database, we can use this C# feature called anonymous types, where we just create a new type on the fly with this new and then curly brace syntax. And in this case, my anonymous type will contain a field called name and a field called serial. If I left those out, and if I just said select p.name and c.serial, then the names of the fields would be name, capital N, and serial, capital S. But one of the great things about anonymous types is it lets us name the fields or rename the fields if we decide we want to change them. So let's just look at the code that we were playing with in class last time. Here is that query from the slide, except I'm maybe selecting a couple of different little things here, but the query itself is players join games on PID equals black player, so give me all the black players. And the result is this thing called query. So it's an IE-numerable of something, but those somethings are just this right here, which is a type that doesn't have a name. It's an anonymous type. So if I want to be able to iterate through that query, I have to do for each var, because there is no other applicable type since it has no name. So x is the range variable. X is going to be each one of those things. We do know that every x will have something called pname and gresult because I gave them those names when I selected them. And then one other thing to point out here is just this using block. Using chess context, db equals new chess context. Chess context is just one of the classes that was created by the scaffolder tool. And it's the class responsible for creating the connection, and it knows all of the information about the various tables and how they connect to each other. And then the example we started looking at was, how do we do a left join? So say we want to get this table out of the library database, where we're getting every title and their serial number or numbers. So we get Harry Potter matched up with 1001 and 2 because it has 2 serial numbers. But we also want every title even if there is no serial number. So in Dune's case, we would get null. And the way to do this in SQL would just be titles left join inventory. So left join gives us everything from the left table, titles, and for the rows that don't have a match, it'll give us null in the columns that are coming from the right side of the join. Problem is LINQ doesn't have a left join keyword, So we use something called a group join in LINQ. It doesn't use the group join keyword or anything, it uses the into keyword. And the way it works is it creates this new temporary data source. So I'm saying titles join inventory on ISBN equals ISBN. So kind of just like a natural join. But I am temporarily putting that into something called right side. And I've renamed it from what the old slide said. I think the old slide said tjoin I or something. But right side is a little more meaningful, because what goes into this temporary data source are things coming out of the right side of this join. So it won't contain information about titles. It'll contain information about inventory objects, since that's on the right side of the join. And the only reason to do this is because if we select from that temporary data source using default if empty, which we'll see in a second, then we will get nulls where there is no inventory object corresponding to the titles object. Otherwise, you wouldn't use into if you just wanted to do a normal join and ignore the ones where there's no match. What this gives us, though, that right side temporary data source, is a list of lists where each sublist is the serial numbers for a particular book. So Dune will give us an empty sublist since there are no serial numbers for it. We don't actually have these titles, though. Those are just my comments. All we really have is these serial numbers. So if we want to get the titles, then we can select them along with selecting something out of that temporary data source. And that looks like this. So I have my original query. This is just from the other slide, where I'm creating the right side temporary data source, and I'm also selecting titles with T. And then what we can do is put another from clause. So I have two froms in this query. And effectively, the way that works is it turns into a nested loop. So I can do from J, or just some range variable, in right side, which is the temporary data source, dot default if empty, which will turn empty lists into a default value, in our case null. So this nested for loop is going to look like this. It'll be for each title, something like Harry Potter, and then for each inventory object in right side, the temporary data source. So we'd get something like Harry Potter matched up with 1 if 1 was one of the serial numbers, HP matched up with 2, and then Lorax or something with its serial numbers. Eventually we'll get down to Dune, and it will be matched up with null. So the outer loop, this from, is the outer loop over titles, and this from is the inner loop over that temporary data source containing serial numbers and null for the ones that didn't have a corresponding matching title. So what this turns into is a single level list of matching titles with serial numbers. So remember that nested loop. Let me go back and show it. I am selecting from that nested loop. I am selecting t.title and j.serial, where j is every object in that temporary data source, including nulls for the empty serial numbers. So if I select just a t.title and a j.serial out of this nested loop, it collapses it into a single level list, matching every title with its corresponding serial numbers or null in the case that it doesn't have any. One small issue here, though, is J, in this case, is sometimes going to be null. And that's the whole point, in fact, is we want nulls where there's no match for the title. But as soon as we try to dereference null, we get a null reference exception. And we saw the way to fix this is we just use a ternary expression to check for null in those J values, and we do that right inside of the select. If J is null, we replace it with some value, whatever we want. Otherwise, we select J.serial. And this will short circuit, and it will never evaluate J dot if J is null. So this will avoid the null reference exception. And this replace val just has to be anything that matches the right type. And so that is where we saw, let me go back to the code. Here's that ternary expression selecting serials. And this is the kind of weird part about this. I'm casting J.serial to a uint question mark, which is a nullable uint. So uints, the primitive types in C# like uint are not by default nullable. Uint question mark is the nullable version of it. And we need to do that because one branch of the ternary expression is returning null. So if we didn't have this, then the other branch of the ternary expression is returning something that is incompatible with the other branch. So you'll see this a lot, casting to uint question mark or int question mark or something like that. You only need to do that on the primitive types. If we were selecting a string or something on this other side, then we wouldn't have to do any casting because strings are already nullable. Any reference type is already nullable. Okay, now what if we wanted this? So extending this example a little bit. Let's say we want the titles and their serial numbers or null if none. And we also want the card num of the person who has checked out the book or null if nobody has checked it out. So here's Harry Potter. One of the copies we do have a serial number for, but nobody has checked it out. So we get at least one null value. In SQL, this is just another LeftJoin. So you could do titles LeftJoin inventory, LeftJoin checked out. And if you wanted to go further and even get the person's name instead of card num, then you could join patrons, but we'll just stop at card number. So this is easy enough in SQL. In LINQ, since we have to emulate a LeftJoin, we start with a group join, just like we've seen. So we do the first group join, titles join inventory into a temporary data source called inv. Then to join that with the next table, we just start writing another join. So join C from checked out into a temporary data source called checked out. So that temporary data source will hold checked out values, and the inv temporary data source will hold inventory values or null if they don't have one corresponding to the left side of the LeftJoin. So it's a bit ugly, and you would just keep going with this. If you had more tables that you needed to LeftJoin, you'll just have from, etc., join, etc., into .default if empty, and then from, etc., join, etc., .default if empty. So it's a little messy in LINQ. You just have a bunch of froms and joins and intos and defaults if empty. But once you understand this pattern, you can just build it up. A, LeftJoin B, LeftJoin C, you just kind of keep going, and this LINQ query will just get longer and longer. LeftJoins are a little unfortunate in LINQ, but they're the worst part of LINQ. Everything else looks great in LINQ and works great in LINQ. Once you understand this pattern, though, it's fine. So look at these range variables, though. We have T, I, J1, J2. Lots of different range variables here. Let's look at what they correspond to. So if this was the table where I've kind of split it into columns, title comes from the titles table. Serial does not come from the inventory table. We want it to come from the temporary data source, which will potentially include nulls. So for serial, to get the serials, we will select something out of J1. And that's what I'm showing here. So the titles come out of the range variable T, serials will come out of J1, and card nums will come out of J2. You just have to remember when you're doing this emulated left join, the range variable that you select from has to be the one that is the temporary data source after the into keyword. So we'll be using J1 because it is selecting out of the inv temporary data source. You might think, well, why not just use I? I is a range variable over inventory objects. Turns out the LINQ syntax just won't even let you use I anymore once you have put it into something with the into keyword. From that point on, we have to use another from and another range variable to select something out of it. So the final query would look something like this now that we have the select. T.titles, and then you'll need ternary expressions for J1 and J2 because they might be null. So you need to convert them into something else in order to avoid the null reference exceptions here and here. And what you convert them into is up to you, or up to the API that you have agreed upon in your MVC architecture. So I will be giving you the API of what the views want. So whatever you decide to put here for your replace vals, you'll just read the provided comments in the handout code. And so if the book doesn't exist, then the serial number should be whatever, some default value. And the instructions will tell you what to replace it with. Okay, so to kind of wrap up this left join stuff, or just weird LINQ queries in general, but like I said, left joins are going to be the weirdest ones. Everything else should make pretty much make sense. If you can't find a good way to write the query using LINQ, just decompose it into more basic LINQ queries first, and then use C# to put everything together. So you could write a C# little method that iterates over the loop, the result of one LINQ query, creates another container, kind of combining it with the results of some other LINQ query, but that should only be a last resort. And don't go the extreme route of just selecting everything from every table and then doing it in C#. You can usually filter it down for the most part with one or two LINQ queries, and then if you really have to, you could use C# logic to create the final JSON result that the view wants back. But once you understand this pattern of multiple left joins, you should just do it, and it'll work great, and it'll be probably even easier than trying to do some hacky workaround in C# logic.